Okay, so we're going to try to explain this formula here for the variance today. We want to try to explain where it comes from and what it's telling us. And I think probably the best way to do that is we are going to start with some data, a very simple data, in order to illustrate this point. So let's have the points 1, 2, 4, and 5. And the first thing we're going to do is we're going to calculate the mean of those points of data. And the mean is given by this formula here, sigma x over n. Now, sigma x means we add up all of these data points. We add up 1 plus 2 plus 4 plus 5, and then we're going to divide through the total number of data, which in this case is 4. So if I do 1 plus 2 plus 4 plus 5, I get 12. And if I do 12 divided by 4, I'm going to get 3. So the mean of this data is 3. Now, it's important to understand at this point what the mean is trying to tell us. The mean is what we call a measure of central tendency. That is a fancy way of saying the mean is telling us where we think the center is. Now, there's no one single way in which we can define the center of a piece of data. We could use the mode, we could use the median to name a couple other examples, but the mean is this particular way. We're going to add up all of our values. We're going to divide by the total number of values. Now, how does that help us when it comes to the concept of the variance? Well, the variance is a measure of the spread of the data, right? In other words, how far it is distributed away from this central point here, this central point of 3. So the way we could do that is we could take the distance of each of these points, 1, 2, 4, and 5, and measure its distance away from 3 there. So let's try to do that. Take the distance by doing each of the x coordinates minus the mean, minus this. So we do 1 minus 3, we're going to get negative 2. 2 minus 3, we get negative 1. 4 minus 3, we get positive 1. And 5 minus 3, we get positive 2. And so we can say, okay, well, we can measure the spread of this data by taking the mean of each of these distances, right? So that would mean that we would add up all of these distances, right? And then divide by 4. But if we do that, we're going to end up with a problem, right? If we say that we add up all the distances and divide by the total number of data points, then we're going to get negative 2 plus negative 1 plus positive 1 plus positive 2 is equal to 0. And in that case, that means that we're going to say that our spread is going to be equal to 0. And that's clearly nonsense, right? That can't be right. And the reason we get that is because we've got these negative values here. So what we want to do is we want to get rid of these negative values so we can kind of turn them into positives. And the simplest way to do that is just to square them. Right, so if I square each of these values, I'm going to get 4, 1, 1, and 4. So now what we're going to do is we're going to say, okay, a way of measuring our spread, right, how far each data point is away from the middle, is to say we are going to do the mean of the distance squared. Right? So we're going to do the mean of the distance squared. In other words, what we're going to do is we're going to add up all of these values here and then divide through by the number of values 4. Now that is what we refer to as the variance, right? The variance is the mean of the distance squared. So in this particular case, what I'm going to do is I'm going to get 4 plus 1 plus 1 plus 4, all divided through by 4, which is 10 upon 4, and that's 5 upon 2. But what we've got here is we've got a variance of our data is 5 upon 2. Well, what I want to do is I want to take that formula there, right? The mean of the distance is squared, and try to rework it a little bit. So I'm just going to go down. All right. Our standard deviation is our mean of the distance is squared. But what is our distance squared? Well, we said that that was the x value minus the mean all squared, right? So in other words, we replace d with x minus the mean. Well, we can then expand this thing here. We expand that bracket. What we'll get if we do that is the summation of x squared minus 2 mu x plus mu squared. And this is all divided through by n. Well, now this thing can actually be split up. Right, so we can split up our summation. This is going to be the same thing as the summation of x squared over n minus the summation of 2 mu x over n. Do that a bit better, sorry. plus the summation of mu squared upon n. Now, there are a couple of things to realize here about summations. Now, the first of that is that this thing here, the 2 mu, that's a constant. We can pull it out of the summation. So let's do that. This is going to be the summation of x squared upon n minus 2 mu times by the summation of x upon n. And then what's going on here? Well, if we've got the summation of mu squared, now mu squared is just a constant. So this summation of mu squared means we're going to do mu squared plus mu squared plus mu squared plus mu squared. We're going to do it n times. So what we're going to end up with there is n lots of mu squared, all divided through by n. Okay, so it's looking a little bit complicated so far, but it is going to simplify. How is it going to simplify? Well, we previously defined the mean, that is mu, as being sigma x upon n. Right, so I can replace this mu here with sigma x upon n. Do that, sigma x upon n times by sigma x upon n. Right, so in other words, I've replaced that mu there with that thing there. I've replaced this thing here with that thing there. Okay? And then if I've got n divided by n, that cancels off, and I'm left with mu squared, and I've just said that mu squared is sigma x upon n all squared, right? So I replace the mu with sigma x upon n. Well, now if we just think about it, this thing is sigma x upon n times by sigma x upon n. Well, that's the same thing as sigma x upon n squared. So I can sort of get rid of this thing like that and replace it with that. So I've got, in summary, sigma x squared upon n minus 2 lots of sigma x upon n squared plus sigma x upon n squared. Well, if I've got minus 2 plus 1, I end up with minus sigma x upon n squared. And that's why we end up with the formula for the variance that you're mostly familiar with, the summation of the x squareds divided by n minus basically the mean, sigma x upon n squared. Okay, so that's where the formula is coming from. But what I hope you see is basically the core idea of the variance, right? The variance is saying, let's find the mean of the distance squareds, right? That's what that thing is, right? We take each of the distances from the middle, from our mean, we square them to get these, and then we find the mean of these values here, right? And what that's telling us is giving us a description of how spread out the data is. Okay, so mean is a measure of central tendency. It's a measure of where the middle is. And the variance, this thing, which is the mean of the distances squared, is a measure of the spread of the data. In other words, how far the data is spread out from that central value in the middle. Okay, I hope that was helpful, guys. See you next time.